Hey science enthusiasts! Today, we're diving into 30 amazing experiments you can do right at home with everyday materials. That's right, you don't need a fancy laboratory to explore the wonders of science. Your kitchen sink will do just fine. We'll be exploring everything from the strange behavior of non-Newtonian fluids to the power of air pressure, the magic of chemical reactions, and so much more. So, put on your thinking caps, grab your safety goggles, better safe than sorry, and let's get started. Ever heard of a substance that can act like a liquid and a solid at the same time? Get ready to meet oobleck. This bizarre goo, named after a Dr. Seuss creation, is a fantastic example of a non-Newtonian fluid. To make your own oobleck, simply mix cornstarch and water. Experiment by squeezing it in your hand, then letting it ooze between your fingers. You'll be amazed by its strange properties. Get ready for an explosive experience as we recreate a volcanic eruption in miniature. Don't worry, there won't be any molten lava involved, just a bit of kitchen chemistry. We'll combine baking soda and vinegar, two common household ingredients, to create a spectacular eruption. This classic experiment demonstrates the reaction between an acid and a base, releasing carbon dioxide gas that causes the eruption. Ever wanted to send secret messages like a spy? With a little lemon juice you can. Invisible ink is a classic science experiment that uses simple chemistry to reveal hidden messages. Simply dip a cotton swab in lemon juice and write your message on a piece of paper. Let it dry completely, and your message will vanish. To reveal the secret message, simply hold the paper up to a heat source, like a light bulb. The heat will cause the lemon juice to oxidize and darken, making your message visible. Chapter 4. Egg Cell and Air Pressure. The incredible shrinking egg. Can you fit an egg through the mouth of a bottle without breaking it? It might sound impossible, but with a little air pressure know-how, we can make it happen. For this experiment, we'll use the power of air pressure to suck a peeled, hard-boiled egg into a bottle. We'll create a vacuum inside the bottle, and the higher air pressure outside will push the egg inside, seemingly defying gravity. Chapter 5. Homemade Lava Lamps. Groovy fluid dynamics in action. Remember those groovy lava lamps from the 70s? Well, get ready to make your own mesmerizing version right at home. It's a fantastic way to explore the principles of density and convection. We'll combine oil, water, food coloring, and an effervescent tablet to create a mesmerizing display of colorful blobs dancing within a bottle. Chapter 6. Blast Off. Building a baking soda rocket. Get ready for launch. We're building our very own rockets powered by the reaction of baking soda and vinegar. It's a fun way to learn about the principles of rocket propulsion. We'll construct a simple rocket using a film canister or a small plastic bottle. Then we'll mix baking soda and vinegar inside to create the fuel that will propel our rocket skyward. Chapter 7. Hair-raising fun. Exploring static electricity. Ever wonder why your hair stands on end when you rub a balloon on it? That's static electricity at work. In this electrifying experiment, we'll explore the science behind static charges. Simply rub a balloon on your hair or a wool sweater to generate static electricity. Then, hold the balloon near small pieces of paper or even a stream of water to see the effects of static attraction and repulsion. Chapter 8. Density Delights. Creating a colorful density column. Did you know that different liquids have different densities? In this experiment, we'll create a colorful density column to demonstrate this scientific principle. We'll carefully layer different liquids, such as honey, corn syrup, dish soap, water, and oil, in a tall glass or cylinder. The liquids will separate based on their densities, creating a visually stunning display. Chapter 9. Slime Time. Exploring the wonderful world of polymers. Get ready for some gooey fun as we delve into the fascinating world of polymers by making our own slime. Slime is a fantastic example of a polymer, a long chain-like molecule made up of repeating units. We'll mix glue, borax solution, and food coloring to create our slime. As we mix, we'll observe how the ingredients interact to form the gooey substance we all know and love. Chapter 10. Magic Milk, a colorful dance of surface tension. Get ready for a mesmerizing display of color and motion with this simple but captivating experiment. We'll use milk, dish soap, and food coloring to create a swirling spectacle that demonstrates the power of surface tension. Simply pour a thin layer of milk into a shallow dish. Add drops of food coloring to the milk. Then, dip a cotton swab coated in dish soap into the milk and watch the colors dance and swirl. Chapter 11. The Egg Drop Challenge. Putting your engineering skills to the test. Can you design and build a protective structure that will prevent an egg from cracking when dropped from a height? This classic science challenge is a fun way to test your engineering skills and learn about impact absorption. Use everyday materials like straws, tape, bubble wrap, or even marshmallows to create a protective cradle for your egg. Then, put your design to the test by dropping it from various heights. Have you ever seen water striders gracefully glide across the surface of a pond? In this experiment, we'll explore the concept of surface tension and learn how these insects manage to walk on water. We'll create our own miniature water striders using paper clips or small pieces of aluminum foil. By carefully placing them on the surface of water, we can observe how surface tension supports their weight. Salty science, exploring the effects of salt on ice. Ever wondered why we sprinkle salt on icy roads in the winter? In this experiment, we'll explore how salt affects the melting point of ice. We'll compare the melting rates of two ice cubes, one sprinkled with salt and one without. You'll be surprised by how quickly the salt melts the ice and learn why it's so effective for de-icing roads. Finding our way. Making a homemade compass. Did you know you can create your own compass using a simple needle and a magnet? In this experiment, we'll explore the Earth's magnetic field and learn how compasses work. We'll magnetize a needle by rubbing it with a magnet. Then, we'll float the magnetized needle on a piece of cork in a bowl of water, creating a simple compass that aligns itself with the Earth's magnetic field. Potato power generating electricity with a DIY battery. Believe it or not, you can generate electricity using simple household items like potatoes or lemons. In this experiment, we'll build a basic potato battery to learn about the flow of electrons and how batteries work. We'll insert zinc and copper electrodes into a potato, creating a simple electrochemical cell. Then, we'll connect multiple potato batteries together to generate enough voltage to power a small LED light. Ever wondered how many different colors are hidden within black ink? In this experiment, we'll use the power of chromatography to separate ink into its individual components. We'll use coffee filters and water to separate the pigments in black marker ink. As the water travels up the coffee filter, it carries the different pigments at different rates, creating a beautiful display of separated colors. Did you know you can create your own weather instrument to measure air pressure changes? In this experiment, we'll build a simple barometer using a balloon and a jar. We'll stretch a balloon over the mouth of a jar and secure it with a rubber band. Then, we'll attach a straw to the balloon's surface. As air pressure changes, the balloon will either inflate or deflate, causing the straw to move and indicate changes in air pressure. Get ready for a slimy and magnetic adventure. We're taking our slime experiment to the next level by adding iron filings, creating a fascinating substance that responds to magnets. Simply mix iron filings into your favorite slime recipe. Then, bring a magnet near the slime and watch in amazement as it reaches out and follows the magnet's pull. Bundle up and head outside on a freezing day for this magical experiment. We're going to blow bubbles and watch as they freeze into delicate, shimmering spheres. Blow bubbles with a bubble wand and watch as they float through the frigid air. The cold temperatures will cause the soap film to freeze, creating beautiful frozen bubbles that sparkle in the sunlight. Ever wondered why a candle flame eventually goes out when you cover it with a glass? In this experiment, we'll explore the role of oxygen in combustion. Light a candle and carefully lower a glass jar over it. Observe what happens to the flame as the oxygen inside the jar is consumed. Did you know that an egg can sink or float depending on the density of the liquid it's in? In this experiment, we'll explore the concepts of density and buoyancy using eggs, water, and salt. We'll fill 2 glasses, one with plain water and the other with a salt solution. Carefully place an egg in each glass and observe whether it sinks or floats. The egg will float in the salt water due to its increased density. Get ready for another round of slime-tastic fun. This time, we're making gak, a stretchy, bouncy substance that's sure to provide hours of entertainment. We'll combine glue, water, and borax to create gak. As we mix, we'll observe how the ingredients interact to form a stretchy polymer that you can poke, pull, and play with. Ever wondered how rain forms? In this experiment, we'll recreate the water cycle in a bag to understand the process of evaporation, condensation, and precipitation. We'll fill a zip-top bag with water, representing a miniature atmosphere. Then, we'll hang the bag in a sunny window. As the sun heats the water, it will evaporate, condense on the sides of the bag, and eventually fall back down as rain. Get ready for another rocket launch, this time using a simple soda can. We'll harness the power of pressure to create a surprising rocket effect. We'll carefully puncture a small hole in the bottom of an empty soda can. Then, we'll add a small amount of water and seal the hole. By heating the can's bottom, we'll create pressure that will eventually launch the can skyward. Who doesn't love ice cream? In this experiment, we'll make our own delicious treat while learning about freezing point depression. We'll combine ice, salt, and the ingredients for ice cream in a zip-top bag. By shaking the bag, we'll lower the freezing point of the ice cream mixture, causing it to freeze and transform into a tasty treat. Get ready for a flight test. We're exploring the principles of aerodynamics by designing and testing different paper airplane designs to see which one flies the farthest. Experiment with different wing shapes, folds, and designs to see how they affect the flight path and distance of your paper airplanes. This is a fun way to learn about lift, drag, and the forces that act on objects in flight. Get ready to create a mesmerizing vortex right before your eyes. In this experiment, we'll simulate the formation of a tornado using 2 bottles and water. We'll fill 1 bottle with water and connect it to an empty bottle using a special connector, or by carefully taping the openings together. By swirling the water in the top bottle, we'll create a vortex that resembles a miniature tornado. Did you know that plants need light to grow? In this experiment, we'll investigate how different types of light affect plant growth. We'll place identical plants in different locations, one in sunlight, one in shade, and one under a grow lamp. Over time, we'll observe and compare their growth patterns to see how light intensity and type influence plant development. Get ready for another rocket launch, this time using the power of air pressure and balloons. We'll build simple balloon rockets to learn about the principles of propulsion. We'll inflate balloons and attach them to straws threaded through a string. By releasing the air from the balloons, we'll create thrust that propels our rockets along the string, demonstrating Newton's third law of motion. Get ready to grow your own sparkling crystals. In this experiment, we'll create a supersaturated solution and watch as crystals slowly form over time. We'll dissolve salt, sugar, or borax in hot water to create a supersaturated solution. Then, we'll suspend a string or pipe cleaner in the solution and wait patiently as crystals begin to grow on the surface. Thanks for joining us on this scientific adventure. We've explored the wonders of oobleck, the explosive power of volcanoes, the magic of invisible ink, and so much more, all from the comfort of our homes. Remember, science is everywhere, and there's always something new to discover. Keep those curious minds engaged. Try out these experiments, and don't be afraid to explore your own scientific ideas. Who knows what amazing discoveries you'll make? Don't forget to like, subscribe, and hit the bell icon for more exciting experiments. See you next time.